everybody. Today we are going to learn the new content, Introduction of Titration Analysis. The two major tasks of analytical chemistry are qualitative analysis and quantitative analysis. In general, a complete process of quantitative analysis includes problem posing, sample collection and preparation, sample determination, data analysis, and output of results. As a quantitative analysis method with high accuracy, chemical analysis lies in the fourth step of quantitative process and used for determination of samples. Chemical analysis is mainly based on the theory of chemical reaction and solution equilibrium. Therefore, to ensure the accuracy of quantitative analysis, it requires that the degree of reaction is no less than 99.9%. Although the degree of reaction depends on the nature of the reaction, it is also inevitably affected by external factors, that is, the secondary reaction. In actual cases, the composition of the reaction solution is complex. The coexisting substance in a sample and a variety of auxiliary reagents added to control the reaction condition are likely to reduce the degree of the main reaction, or even not meet the requirements of quantitative analysis. According to different reaction types, titration analysis can be divided into acid-base titration, complexometric titration, redox titration, and precipitation titration. In this chapter, we will learn about the commonality of titration analysis. First of all, what is titration? When we add a solution with a known concentration to an Erlenmeyer flask with a burette, the process is called titration. The sample content can be calculated by the concentration of standard solution and its consumed volume, which is called titration analysis. In the process of titration, when the standard solution reacts completely with the analyte in accordance with the stoichiometric relation expressed in chemical equation, this position is called stoichiometric point, usually represented as Sp. Take titration of sodium hydroxide with hydrochloric acid, for example. When the added hydrochloric acid reacts completely with sodium hydroxide in the sample solution with the amount ratio of 1:1, it is the stoichiometric point. In general, since there's no obvious change about the appearance of the sample at the stoichiometric point, we need to add the appropriate indicator whose color changes obviously when titration near to the stoichiometric point. This position is named as endpoint, usually represented by EP. The endpoint is the actual result, while the stoichiometric point is a theoretical value, and the analytical error caused by the inconsistence of the titration endpoint and the stoichiometric point is endpoint error. In titration analysis, we hope to terminate the titration when the endpoint agrees with the stoichiometric point, but it's actually hard to achieve this, so the error is always present. Now, let's move to the other important concept in titration analysis, including titration curve, titration jump, and jump range. In the experiment, titrating hydrochloric acid with sodium hydroxide using phenolphthalein as an indicator. Sodium hydroxide is titrant, and hydraulic acid is the analyte. With the successive addition of sodium hydroxide, the color of the solution changes from colorless to reddish, indicating that it reaches the titration end. Taking the added amount of sodium hydroxide as the horizontal axis and the pH value of the solution as a vertical axis, we can draw the blue curve in the figure. It is the titration curve we usually talked about. It can reflect the process of titration and exhibit the changes of the analyte in the solution with the addition of titrant. From the titration curve, it can also be found that titration curve presents symmetrical distribution centered on stoichiometric points. The solution pH near to stoichiometric point changes dramatically with order of magnitude, so that the middle part of the titration curve is almost vertical. This phenomenon is called titration jump, which can also be seen by the titration differential curve. For different titration methods based on different chemical reactions, titration jump is a common phenomenon, which provides the possibility for quantitative analysis. In general, the titration analysis is fast, accurate, convenient, cheap, simple, and suitable for the determination of various analytes. That's all for today. Thank you for your attention.